Linear equations definition. Linear equations are first-order equations with two variables. They are called linear because their graph is a straight line. Let's prove this statement. Let's consider a first-order equation with two variables, for example 2x minus y plus 1 is equal to 0. To solve this equation means to find all possible combinations of the variables x and y that make the left part of the equation 0, i.e. that give a true result. Obviously, there is an infinity of combinations that meet this condition. All these points lie on the graph. We are giving a few of them. For x equals 0, we have 2. 0 minus y plus 1 is equal to 0, so y equals 1. Hence, the number pair 0, 1 is a point of the graph. For x equals 1, we have 2. 1 minus y plus 1 is equal to 0, so y equals 3. Hence, the number pair 1, 3 is a point of the graph. For x equals 2, we have 2. 2 minus y plus 1 is equal to 0, so y equals 5. Hence, the number pair 2, 5 is a point of the graph. For x equals 3, we have 2. 3 minus y plus 1 is equal to 0, so y equals 7. Hence, the number pair 3, 7 is a point of the graph. For x equals 4, we have 2. For minus y plus 1 is equal to 0, so y equals 9. Hence, the number pair 4, 9 is a point of the graph, and so on. Let's plot all the following points in a coordinate system. We have the following shown on screen. It is clear that all these points are collinear. We can connect them with each other so that we obtain a straight line known as a linear graph. We have the following shown on screen. Obviously, we can extend the line beyond the points we found earlier. Moreover, it is worth highlighting the fact that not only integers are included in the graph, it contains all possible pairs of real numbers that make the equation true as well. In fact, from geometry, it is known that we need to have only 2 points known to draw a line. Therefore, with just 2 pairs of coordinates, we can successfully plot a linear graph. It is preferred that these 2 points be the intercepts with the x minus and y minus axes, i.e. the points a, 0, y, the y minus intercept, and b, x, 0, the x minus intercept, but it is up to you to choose the points you see as the most appropriate. Example. Check whether points a, 3, minus 4, b, minus 5, 0, and c, minus 2, 5, lie on the graph of the linear equation x minus 2y plus 5 is equal to 0. Solution. All we have to do is to substitute the coordinates of each point in the equation and check whether they give a true result, i.e. the left part of the equation must be 0 after substitutions. Thus, for point A, x equals 3, y equals minus 4, we have the following shown on screen. This means that point A is not a point on the graph of our equation. As for point B, x equals minus 5, y equals 0, we have the following shown on screen. This means that point B is a point on the graph of our equation. Last, for point C, x equals minus 2, y equals 5, we have the following shown on screen. This means that point C is not a point on the graph of our equation. The 3 points A, B and C as well as the graph of the linear equation x minus 2y plus 5 is equal to 0 are shown in the graph. We have the following shown on screen. That is all for lesson 9.7.1. To continue this tutorial, please watch 9.7.2, Systems of Linear Equations. Thank you for watching. Make sure to like and subscribe to keep up to date with new videos. For more information, calculators, and tutorials, please visit www.icalculator.info.